Wave equation. What is wave equation? A plane propagative harmonic wave traveling along positive x direction may be represented as number 1 y equal to a sine omega t minus kx, where k is 2 pi upon lambda. Second is y equal to a sine 2 pi t upon t minus x upon lambda. And third is y equal to a sine 2 pi upon t vt minus x, where v is the wave velocity and lambda is the wavelength. A is the amplitude of the oscillating particle and y is the displacement of the particle in the direction of x. If the wave is traveling along negative x direction, the minus sign is replaced by the plus sign. That will be equal to a sine omega t plus kx, k is 2 pi upon lambda, y equal to a sine 2 pi t upon t plus x upon lambda. Third is y equal to a sine 2 pi upon t vt plus x. Now I will talk about phase and phase difference. What is phase and phase difference? Phase is the argument of the sine or cosine representing the wave. Phi equal to 2 pi t upon t minus x upon lambda. The relation between phase difference delta phi and time interval delta t is given by delta phi equal to 2 pi upon t into delta t small t. Thus, in time period t, the phase of the particle changes by 2 pi. The relation between phase difference delta phi and path difference delta x is given by delta phi equal to minus 2 pi upon lambda into delta x. The negative sign indicates that the farther the particle is located from the origin in the positive direction x, the more it lags behind its phase. Negative sign indicates that the farther the particle is located from the origin in the positive x direction, the more it lags behind its phase. Clearly, the phase difference between two particles located at separation lambda will be 2 pi. Now I will talk about principle of superposition of waves. When a number of waves travel through a medium simultaneously, the resultant displacement at any point of the medium is equal to the vector sum of the displacements of the individual waves. If y1, vector y1, vector y2, vector y3, vector y4, dash, 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 vector yn are the displacements of n waves superposing each other at a point, then the resultant displacement at that point will be vector y equal to vector y1 plus vector y2 plus vector y3 plus vector y4 plus dash, 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 vector yn. Stationary waves. What are stationary waves? When two progressive waves of equal amplitude and frequency traveling in opposite directions along a straight line superpose each other, the resultant wave does not travel in either direction and is called stationary or standing wave. I am repeating once again the statement. When two progressive waves of equal amplitude and frequency traveling in opposite directions along a straight line superpose each other, the resultant wave does not travel in either direction and is called stationary or standing wave. At some points, the positions of medium always remains at rest. These are called nodes. At some points, the particles of the medium always remains at rest. These points are called nodes. At some points, the amplitude of oscillations is maximum. These points are called antinodes. When amplitude will be maximum, these points are called antinodes. Consider a plane progressive harmonic wave traveling along positive x direction. y1 equal to a sine omega t minus kx. This is called incident wave. This wave is reflected from a field. Then y2, after reflection, the wave will be y2 equal to a sine omega t plus kf. This is reflected wave. The stationary wave formed by a superposition of the incident and reflected wave will be the stationary wave formed by the superposition of the incident and reflected wave will be y equal to y1 plus y2, and that will be equal to 2a cos kx sin omega t. In this case, the point x is 0, lambda upon 2, 3 lambda upon 2 will form antinode. Antinodes will be at x equal to 0, lambda upon 2, 3 lambda upon 2. At the point x equal to lambda upon 4, 3 lambda upon 4, 5 lambda upon 4, it will be nodes. At these points, nodes will be formed. At x equal to lambda upon 4, 3 lambda upon 4, 5 lambda upon 4. If the wave is reflected from a rigid end, then y2 equal to minus a sine omega t plus kf. The equation of the stationary wave will be equal to y equal to minus 2a sine kx cos omega t. In this case, the point x equal to 0, lambda upon 2, lambda, 3 lambda upon 2 will be nodes. At these points, nodes will be formed. And the points at x equal to lambda upon 4, 3 lambda upon 4, 5 lambda upon 4, at these points, antinodes will be formed. These points will be antinodes. Separation between two successive nodes and antinodes will be equal to lambda upon 2. Separation between two successive nodes or separation between two successive antinodes will be lambda upon 2. Successive nodes lambda upon 2 and two successive antinodes will be also lambda upon 2. Separation between a nodes and nearest antinode. Separation between a node and nearest antinode will be equal to lambda upon 4. Now I am moving modes of vibrations of strings. Modes, not notes, modes. Modes of vibrations of strings. On a stretched string, the transverse stationary waves are formed due to the superposition of direct and reflected transverse waves. On a stretched string, the transverse stationary waves are formed due to superposition of direct and reflected transverse waves. Lambda 1 equal to 2L. For fundamental mode, lambda 1 equal to 2L. V1 equal to V upon lambda 1 or 1 upon 2L under root T upon M. For second mode, lambda 2 equal to L. V2 equal to 2V, second harmonic or first overtone. Lambda 3 equal to 2L upon 3, V3 equal to 3V, third harmonic or third overtone. Laws of transverse vibrations of a stretched string. Laws of transverse vibrations of a stretched string. The fundamental frequency of a vibrating is first inversely proportional to its length. V directly proportional to 1 upon L. This is the law of length. Second is directly proportional to the square root of the tension. V is directly proportional to under root T. This is called law of tension. V equal to under root 2. This is called law of tension. And V equal to 1, V is directly proportional to 1 upon L. This is called law of length. Meaning that if the length is increased of the stretched instrument, then the speed will be decreased. Third is inversely proportional to its mass per unit length. V is directly proportional to under root 1 upon M. This is called law of mass. Then what is law of length? V is directly proportional to 1 upon L, meaning that If L is increase, if L is if L is increasing, then V will be decreasing. V is directly proportional to under root T. If tension is increasing, V is increasing. V is directly proportional to under root 1 upon M. If M is increasing, then V will be decreasing. Combining all the factors, V equal to 1 upon 2L under root 2 upon M, under root T upon M, or 1 upon LD under root T upon pi rho. Here rho is the density and D is the diameter of the string. Doppler effect in sound. What is Doppler effect in sound? The phenomena of the change in apparent pitch of sound due to relative motion between the source of sound and the observer is called Doppler effect. The phenomenon of the change in apparent pitch of sound due to the relative motion between the source of sound and the observation is called Doppler effect. If V0 and Vs and Vm are the velocity, V is the velocity of sound, V0 is the velocity of observer, Vs is the velocity of source, and Vm is the velocity of medium. Then the apparent frequency is given by V dash equal to V plus Vm minus V0 upon V plus Vm minus Vs into V. For the medium at rest, if the medium is at rest, Vm equal to 0, then V dash equal to V minus V0 upon V minus V0 into nu. Nu means frequency of the sound. Here the velocities are taken positive in the source to the observer. Here the velocities are taken positive in the source to observer. The direction and negative to the observer. If direction is negative, if it is taken from observer to source, the direction will be negative. Some are special cases. First is when the source moves forward, the stationary observer. When the source moves, when the sounding source is moving and observer is stationary, meaning that at rest, then nu equal to V minus V upon V minus V0 Vs into V. Second is when the source moves from the stationary observer, then V dash equal to nu dash equal to V upon V plus Vs into V into nu. When the observer moves towards the stationary source, when the observer moves towards the stationary source, nu dash equal to V plus V0 upon V into nu. Fourth is when the observer moves away from the stationary source. When the observer moves away from the stationary source, then nu dash equal to V minus V0 upon V into nu. When both source and observer moves towards each other. When both source and observer moves towards each other, then nu dash equal to V plus V0 upon V minus V0 Vs into nu. When both source and observer move away from each other, when both source and observer move away from each other, then nu dash equal to V minus V0 upon V plus Vs into nu. If you like my video, please like and subscribe my channel. Thank you.